Hello, everyone. This is an addendum to my original section 2.8 lecture. I wanted to go back and specifically discuss domains of inverses because I did not cover it in enough detail, or really at all, in my original lecture, and it is good to see. And I might ask you some questions about it on homework or tests. So I wanted to actually give you the material so that you could learn it. So when we're computing the domains of inverses, it's tempting to just compute it using the methods we already know after calculating the inverse. But technically, that is not a correct answer. So here's the rule. Is that the domain of some inverse function, f inverse, is the range of your original function f. The reason for that is because when we look at f and f inverse and how they play together, we want their domains and ranges to match up nicely. And if they don't, then things can break, and we don't like breaking things. So this might seem like weird and contrived, but it does serve a purpose. So let's look at some examples of this. So let's see, our first example, let's say, so consider, that's not a D, consider, let's do f of x equals the square root of x. Fairly simple, we've seen this before. So we already know, and if you didn't know this, you can go ahead and just calculate it. It's not terribly difficult, but the inverse of this is just going to be x squared. So the question is, does the domain, so of the inverse, does that equal all of R? Sorry, that should be a question mark. And it's tempting to say yes, but the problem is that the range of the square root function is not all of R. So, nope. So we know that from our rule above, the domain of f inverse is the range of f. Okay. And we know from previous lectures that the range of the square root function is going to be the interval 0 to infinity, including 0. So the domain of this inverse function in this context is actually 0 to infinity, not all of R. Again, this seems contrived and weird because obviously you can square things that are negative, but in this context, it is more correct and oftentimes more helpful to look at it this way. Maybe let's look at another example. Let's say we have, f of x. Let's do 2 over x. You can calculate, again, using techniques we've already discussed, that the inverse function to this, so f inverse, is going to be 1 over 2 of x. So here, so does domain of the f inverse equal, and so because this is a rational function, we already know that the domain, if we were just look at it out of context, 1 over 2x, the domain should be all the real numbers except 0, right? Can't plug in 0, but we can put everything else in. And the answer to this is yes, because our rule says so. So the domain of f inverse is the range of f. And in this case, f is 2 over x. And the range of that, we know that it can't equal 0 anywhere from previous lectures. And so this, again, is going to be R take away 0. So that checks out. So in summary, remember this rule up here. And I know it seems arbitrary, but I promise it is important.